dioxide, which has gone over 400 parts per million, or about 0.04%. And this has positive feedbacks with time lags that can, they come from the effect of these greenhouse gases. Now, the greenhouse gases are, in fact, water, the primary one, but it's an amplifier of the heating which comes from the carbon dioxide. And then there's also methane, or CH4. So this is what's causing the temperature rise. And if we don't limit the temperature to this 2 degrees centigrade of warming maximum, then, as I'm going to show, it could lead to the runaway greenhouse effect. So we need to limit the CO2 to under 450 parts per million. And inertia is going to probably carry us very close to that, as you read from Craig Hover's book. So we know that for the last 60 years, carbon dioxide has been going up because we've been measuring it very accurately at Mauna Loa. And there's an up and down yearly cycle, but that we know the net increase has come from the carbon dioxide we put into the air from burning fossil fuel. For instance, about a third of it comes from burning coal to make electricity, a third from oil to make transportation happen, and a third from gas burning to do industry and heating. That's what causes the net increase here. In fact, for 400,000 years, the temperature here in blue and the CO2 in red has been going up and down together. And it's been going up and down in these 100,000-year ice age cycles. Those are punctuated by interglacials, which last about 10,000 years, you see. And for the last million years now, we know that this red, this carbon dioxide didn't go above 300 parts per million, but in the last 100 years, and this is an accurate graph in that scale, it went from below 300 up to 400 and above parts per million. Just in the last 2 years, it got to that high, whereas it hadn't been above 300 in the last million years. So this is very revolutionary. This is very different for the Earth, and we're the ones that did it. So, Earth's atmosphere is very thin, kind of like the rind on an orange, like 50 miles deep. And it turns out that this is a blanket of air that keeps the Earth warm. Without that blanket, the Earth's oceans would be frozen over and we'd have a snowball planet. The way it works is in the prehistoric Earth, the natural greenhouse effect from sunlight shining on the Earth and then re-radiating as heat. Like when you go out on the beach, you feel the heat coming from the sand or from hot rocks. That's the infrared coming back up from the Earth. And this naturally increases the temperature of the Earth by about 70 degrees Fahrenheit. So with the human industry making an extra thick blanket of CO2 here around the Earth, we have an enhanced greenhouse effect that artificially increases the Earth temperature by trapping that heat within the blanket of the atmosphere. And it makes it about 1.5 degrees Fahrenheit or 1 degree centigrade hotter than it was previously. The warming cycle of the Earth actually has a lag time for the ice to melt, so think about it. The sun shines on these snowfields in the Arctic, and it's white, so it just bounces off. It doesn't get absorbed, right? However, if that ice melts into either the Arctic Sea or the tundra here, dark colors absorb light. So that sunlight goes down and it's absorbed. That increases the warming. So this is called a self-reinforcing or positive feedback effect. Methane gas actually bubble up from that Arctic Sea or from the released from tundra. Here you can see the methane ice trapped, frozen in the Arctic ice. Those are bubbles that are trapped in the ice. But when the ice is gone, it simply bubbles up into the atmosphere, kind of like from an underwater volcano of methane. And that methane is previously trapped as a methane hydrate that's down on the continental shelf, sometimes 100 feet thick. But when the sea gets warmed, these methane hydrates come erupting up and they bubble up. And you can see here that if you light them up, it's just like swamp gas burning, it makes a huge torch. And these people are getting warmed by it there in the Antarctic, standing on the ice. So the global warming positive feedback cycles are easy to understand if you just follow it around the circle. The sunlight, of course, is the source of energy, which warms the ocean and warms the air. And now we'll follow it over here. The warming ocean has 3 different effects that are positive feedback. First of all, the water vapor evaporates from the warm ocean. That water vapor is the major